Okay, we will continue with solutions method for second order linear differential equations. So we will start with reduction of order methods. Okay, let's continue. So I write down the some technical parts, but I will continue with solving examples. Okay, given y1 a solution of a homogeneous second order differential equation, we have second order linear. Since it is equal to 0, it is a homogeneous second order linear differential equation. And if a solution y1 is given, we need to find a second solution, and there is a method to find the second solution. So if we assume y2 is equal to y1 times v, where v is a function of x, some function of x, and if we assume this, y2 is equal to y1 times v, and when we substitute in the equation, in this equation, y double prime pxy prime plus qxy, when we substitute y2 into this differential equation, we can find y2, because when we substitute, then the equation, second order differential equation, reduces to first order separable differential equation, and we know these are very easy to solve. Okay, let's see this. So let's see this technical parts. So let's say y1 is a solution of this equation star. Okay, let's see. So this equation star. That is, when we put substitute y1 into equation, it satisfies the equation and it is equal to 0. Okay, let's put y2 is equal to y1 times v. So to do that, we need to take the first derivative and second derivative of y2. So we take the first derivative and second derivative, and then we substitute in the equation, in this equation star. Okay, when we take the first derivative, so we have y2 times v, so we apply the product rule. So remember the product rule. So when we have a product of a function, and when we take its derivative, we take it like this. So derivative of first one times the second one plus u times the derivative of second one. So this is a product rule. Okay, we apply this product rule. So the derivative of y1 times v plus y1 times the derivative of the second one. And when we take the second derivative, we use the same idea. Again, the product rule. And we get the second derivative. Now we substitute in the equation star, and we will see that we just substitute y2 double prime, y2 prime, and y2 in the equation. Y2 in the equation. So, okay, we put y2 double prime here, and y2 here, and this is y2. Great. And then when we take v parentheses, we see that the coefficient of the v parentheses is just y1 double prime plus px y1 prime plus qx y1. And since we know that y1 is a solution, we know this is 0, right? Because y1 is a solution of this equation and it satisfies it. So we have 0 here. We take v parentheses. And okay, and we have a very nice differential equation. We have something very nice. When we put v prime is equal to w and v double prime is equal to w prime, then the equation reduces to a separable equation, and we know they are very easy to solve. Okay, now let me solve one example so that you will understand better. Okay, let's continue with example. Okay, given y is equal to x is a solution of, so x squared y double prime minus 4x y prime plus 4y is equal to 0, using reduction of order method, find the general solution. Okay, let's say this is y1 is equal to x, so that we will not be confused. So given y1 is equal to x is a solution of this homogeneous differential equation. Now, and it says using reduction of order method. So we know that we will let y2 to be y1 times v, and in this case y1 is given as x, so we have y2 is x times v. Now take its derivative and substitute in the equation. In the given equation. So this is all you need to know, because then the rest is very simple. So, but you should know that you should assume y2 is equal to y1 times v to find the second solution. Okay, then what is okay, let me write y2 is equal to x times v. Y1 prime is equal to the product rule. What is the derivative of x? It is 1 times v plus x times v prime, and we take the second derivative, so this is equal to v plus xv prime. What is the second derivative? V prime plus the derivative of x is equal to 1, so 1 times v prime plus x times v double prime, so this is 2v prime plus xv double prime. And then now substitute in x squared y2 double prime minus 4x y2 prime plus 4 y2 is equal to 0, so we assume that this is the second solution. Now we will put it in the equation, so we have 2v prime plus v double prime minus 4x v plus xv prime plus 4x times v is equal to 0. Okay, now let's distribute the coefficients, and x cubed v double prime minus 4xv minus 4x squared v prime plus 4xv is equal to 0. So let's simplify things. Okay, you see that these two terms will cancel, and what we are left? We are left with x cubed v double prime minus 2x squared v prime is equal to 0. Or we can write, we can cancel, divide by x squared, right? So we will have x v double prime minus 2 v prime is equal to 0. Now we will let v prime is equal to w and v double prime is equal to w prime, so that we will have a separable differential equation, right? So this is separable because we know that this v prime is equal to dw over dx minus 2w is equal to 0, and what we have, dw over dx 2w, and from here we can write dw over w is equal to 2 over x dx, and when we integrate, so we will find ln w is equal to 2 ln x, let's say plus c. Now we want just add, sorry, then what was w? Okay, we can here, so we want just a function y2, so we can choose c is equal to 0 here. So ln w is equal to, and we can write like this, so we can take 2 inside as a square, and so we will have w is equal to, so we can take w is equal to x squared, right? Okay, but w was v prime, so w is equal to v prime is equal to x squared. So if v prime is x squared, then what is v? So we are looking for v, right? So this is x cubed over 3 plus c. Okay, we continue here. So we find, okay, I will write it again here, plus c, but again choose c is equal to 0, because at the end we will add some c, some constant to the equation. Now we can choose c to be 0, so v is equal to x cubed over 3, and what was y2? It was y1 times the function v. V is a function of some function of x. y1 was given, it was given x, and we find v to be x cubed over cube. So okay, then what is y1 is x, now y2 is equal to x to the power 4 over 3. So what is the general solution? General solution, we can sometimes write y general, so it is c1 y1 plus c2 y2. So y general is c1 x plus c2 x to the power 3. So because of this constant c1 and c2, we can choose c to be 0. So we want the simplest one. So because if we add here plus c, I mean c2 times c, we can again write some constants instead of, I mean, we write a general constant here, so we don't need to, we look for the simplest form of y1 and y2. That's why we choose in the process c is equal to 0. Okay, let's solve another one. Okay, example. Now, given y1 is equal to e to the power 2x is a solution of uh, 2x plus 1 y double prime minus 4 x plus 1 y prime plus 4y is equal to 0. Find the general solution. Find the general solution by using reduction of order method. Great. So here all you need to know that if it says reduction of order method, now we can assume y2 to be y1 times v be the second solution. So we will assume this, and this time y1 is given as e to the 2 power 2x times v. So this is all we need. We need to know to solve the differential equation, and we will substitute this in the equation, and we will find y2. We said y2 is equal to e to the power 2x times v. To substitute, I need to find the first derivative and the second derivative. So I find the second derivative using product rule. Recall u times v is equal to u prime v plus uv prime. So this is the product rule. What is the derivative of e to the power 2x? It is 2 times e to the power 2x v plus e to the power 2x v prime. Now we take the second derivative. So now we have 4 times e to the power 2x v plus 2 e to the power 2x v prime plus 2 e to the power 2x v prime plus 2x v double prime. And we can simplify this as 4 e to the power 2x v plus 4 2x v prime plus v double prime. Now substitute in the equation y2 prime, y2 double prime in the equation, into the equation, substitute into the equation. Now we will substitute. What was the equation? Okay, I will check from my notes. So it was given like this: y2 double prime minus 4x plus 1 y2 prime plus 4 y2 is equal to 0. Okay, now we will substitute y2 double prime. So okay, let's continue. 2x plus 1 y2 double prime. So we find it for e to the power 2xv plus 2xv prime plus e to the power 2xv double prime minus 4x plus 1 y2 prime 2 e to the power 2xv plus e to the power 2xv prime, and we have plus 4y2. So y2 was e to the power 2xv is equal to 0. So we need to be careful about calculations, but we see that so every term has this e to the power 2x. We can take e to the power 2x parentheses and cancel. So we can cancel e to the power 2x. Now 2x times 4v, so we 8x v plus 4v. Okay, now we will multiply plus 8x v prime plus 4v prime. Okay, we don't have any other v double prime, so we have minus 8x v minus 8v minus 4x v prime minus 4v prime plus 4v is equal to 0. Let's see what we have. So we have 8xv minus 8xv, so we have 4v here minus 8v here, 4v here, all will cancel. So we have 8x v prime minus 4x v prime. We are left with 4x v prime, and this also will cancel for v prime minus 4v prime, plus we have 2x plus 1, v double prime is equal to 0. Now what we are going to do is, let v prime to be w, v double prime to be w prime. So now we will have a separable differential equation, plus 4x v prime is equal to 0. So we have 2x plus 1 v prime plus 4x w is equal to 0. Now we have a separable differential equation. So we know w prime is equal to dw over dx. So we can write 2x plus 1 w prime dw over dx is equal to minus 4x w. So we can write dw over dw is minus 4x over 2x plus 1 dx. Now this is, so now we have separable first order differential equation. So we will find w first, and then we will find v. Okay, how now? Of course, if you don't know how to integrate minus 4x over 2x plus 1, then we have a problem, right? So you should remember integration techniques. So here we should divide minus 4x to 2x over 4. So we have 4x plus 2, so minus, so minus 2. Here we have dw over 2. So we can write here, sorry, this is minus, this should be minus 2. So we have minus 2 plus 2 over 2x plus 1 dx. Okay, let me copy it here to the next page. Okay, now we know that here is ln w. What is the derivative? Minus 2x plus 2 times ln 2x plus 1 over 2. So recall that what is the derivative? 1 over ax plus b dx. So we know that this is ln x plus b over a plus c, right? Great. So what is w? We can cancel this 2's. So ln w is equal to, okay, that is actually absolute value, minus 2x ln 2x plus 1. So we can write w as e to the power minus 2x plus ln 2x plus 1. So we can write it like this, e to the power ln 2x plus 1. So we can choose, assuming that everything is positive, so choose w as you can see, I didn't write c, so choose c is equal to 0 everywhere. So we have e to the power minus 2x times 2x plus 1. So if you have e to the power ln x, so the rule is this is equal to x, and if you have a plus b, we can write it e to the power a times e to the power b. So I use those rules. So now we know what is W. Now, oh no, oh, this is very hard integration. Oh, I choose this example from the book. Okay. And we know this is equal to W is equal to, W is equal to V prime. So to find V, we will integrate e to the power minus 2x plus minus 2x. So I just multiply. And I see integration by parts there. Oh no, we don't. Yeah, yes, integration by parts. No. Okay, x times e to the power minus 2x dx. Integration by parts. So this is u times dv, u times v minus v du. What is u? X is equal to u e to the power minus 2x dx is equal to dv. So we should find du, dx is equal to du, and we should find v. So minus 2x minus 2 is equal to v. And the solution is u times v, x times e to the power minus 2x minus 2 minus v du. What is v? Dx, so this is minus x over 2 e to the power minus 2x plus 1 over 2 e to the power minus 2x dx, and here is minus 2x over minus 2, so the answer is over 2 minus 1 over 4 e to the power minus 2x plus c, but choose c is equal to 0. So what is so we have v prime is equal to 2 times x e to the power minus 2x dx plus e to the power minus 2x dx. So here is v is equal to 2 times x times e to the power minus 2x minus x minus 2x over 2 minus 1 over 4 e to the power minus 2x plus, so what is this integral, plus c again, so c is 0. Okay, do we have any cancellations? Minus, so v is equal to minus x e to the power minus 2x minus 1 over 2 minus 1 over 2. So v is minus x e to the power minus 2x minus e to the power minus 2x. So at last we find v. So let me check, do I make it correct? Yes, great, it is correct. So v is equal to minus x e to the power minus 2x minus e to the power minus 2x. Then what is y2? y2 was y1 times v, and y1 is given as e to the power 2x. Okay, maybe I will write it like this, minus x minus 1 e to the power minus 2x. So what we have, x plus 1 e to the power 2x minus 2x. So this is e to the power 0, which is 1. It is minus x plus 1. Great. So we find something nice. So y2 is minus x plus 1 and y1 is equal to e to the power 2x. Then the general solution is y general is c1 y1 plus c2 y2. So it is c1 e to the power 2x plus c2 minus c2 minus x plus 1, or you can c1 e to the power 2x. Yeah, great, you can leave it like this. Okay, this is the general solution. Great. Okay, I write down some exercises for you. So you will solve using reduction of order method. So you will solve exactly in the same way. Just assume y2, the second solution y2 is of the form y1v and solve. So just you will solve all these two examples in this way.